Hello, so this is a revision video for IB Chemistry S2.1.1, Formation of Ions and Predicting Charge. An ion is a charged particle that forms when atoms gain or lose electrons. Cations are positively charged ions formed when an atom loses electrons. Anions are negatively charged ions formed when an atom gains electrons. Exam tip here: metals usually lose electrons and form cations, and nonmetals usually gain electrons and form anions. However, there are exceptions, so it's always better to look at how electrons are being transferred rather than the type of element reacting. For example, when sodium and chlorine react together, sodium atoms lose one electron and become positively charged ions, and chlorine atoms gain one electron and become negatively charged chloride ions. Atoms of elements lose or gain electrons to achieve a stable electron configuration, usually a noble gas configuration. The most likely charge of an ion can be predicted from how many electrons an atom is likely to gain or lose. For example, magnesium has an electron configuration of Ne3s2, and so readily loses 2 electrons to form Mg2+. Oxygen has an electron configuration of He2s2, 2p4, and so readily gains 2 electrons, forming O2-, and a configuration of He2s2, 2p6. We can usually predict the ionic charge for an ion of an element from its position in the periodic table. Group 1 metals form positive 1 ions, Group 2 metals form positive 2 ions, Group 6 nonmetals form negative 2 ions, and Group 7 nonmetals form negative 1 ions. This is based on the idea that the atoms will lose or gain electrons to get a full outer shell. Transition metals can have variable charges, which we can represent using Roman numerals in their names. For example, a name that includes ion 2 means it has Fe2+ ions in, and a name that includes ion 3 means Fe3+ ions. The ability of transition metals to form different charged ions happens because transition metals have partially filled d subshells, and successive ionization energies for 4s and 3d electrons are relatively close together. As a result, the energy difference between different charged ions is small, and this allows transition metals to lose different numbers of electrons and form multiple charged ions that can be interchanged relatively easily, making them useful catalysts.